Man, I'm never gonna pass Miss Nelson's pH test. This is pointless.
Let's say pH.
pH, Peter? What are you doing here, man?
Heard you need some help on a chem test, dude.
Oh,
Ready to
man.
help.
Thanks, man. Alright, let's go inside. I'm gonna pass Miss Nelson's test. Yeah! pH, Peter, it has been 5 hours. 5 hours, and you haven't taught me anything. Not a single thing.
pH is everywhere. Look at this. This is extremely basic. pH 14.
Oh, wow. But pH, Peter, what exactly is the pH?
Dude, it tells us the relative quantity of H plus ions in a solution, also known as acidity.
So the greater the H plus ions in a solution, the lower the pH?
Yes, that's right.
pH, Peter, what about the hydronium and the hydroxide concentration in pure water?
Ionization of water. Small quantities of water molecules. And a sample will self-ionize.
So, pH, Peter, what you're saying is this results in a small but equal hydronium and hydroxide concentration, which means these ions' pH will equal 7?
Huh?
So what happens when acid is added to water?
Well, when acid is added to water, it increases the hydronium concentration.
So basically what you have on your shirt means that hydronium becomes greater than hydroxide.
What about when a base is added to water?
Oh, well when a base is added to water, it increases the hydroxide concentration.
pH, Peter. So when a base is added to water, the hydroxide concentration becomes higher than the hydronium concentration. That's pretty easy. Here's a basic summary. When acid is added to water, the hydronium concentration becomes higher than the hydroxide concentration. When a base is added to water, the hydroxide concentration becomes higher than the hydronium concentration. And when it's neutral, hydronium will equal hydroxide, which means its pH will be 7. Peter, what about different pH indicators?
Dude, pH indicators? Why don't you say so? They're all here on my shirt. Check them out.
Oh, wow. Okay, so this one, for example, litmus, the most famous example of an indicator, changes from red to blue.
You're right. I got some litmus paper right here. Let's try it out. See? Just got to give it a little bit of a dunk. Come on. Come on. Just put a little bit. And then you see, look, changes straight to red.
Oh, wow. So it means its range was approximately 4.5 to 8.3. Other indicators, there's methyl orange, which changes red to yellow. There's bromthiamyl blue, which changes yellow to blue. There's phenolphthalein, which changes colorless to pink. There's litmus, that we already covered, red to blue. There's bromcresol green, which changes yellow to blue. And then there's thymol blue, which changes yellow to blue again.
You know it.
pH, Peter, what about the pH scale?
What do you need to know, kid?
Oh, wait, it's right here. So on the pH scale, it basically tells us what's acidic, what's neutral, and what's basic. Anything that has a pH from 0 to 6 is acidic. Anything that's neutral has a pH of 7. And anything that has a pH rating of 8 to 14 is basic. What's a neutralization reaction?
Take a look. It's here on my shirt.
Oh, okay. A double replacement. Hydrogen chloride plus sodium hydroxide equals sodium chloride and water.
Now you're getting it.
A double replacement occurs when ions switch partners and water is formed. Peter, how do I complete a neutralization equation?
Those equations right here, my dude.
Oh, okay. Completing and balancing neutralization equations. You first have to write the charges for ions in an acid and a base. Switch the ion partners. Positive ions stay in front always. Do not bring over subscripts except for if part of a polyatomic ion. That's the important part. Crisscross charges to balance the formulas, and then balance the entire equation.
Crisscross.
Name the acid, base, and salt. And help think that I'm forgetting something, pH, Peter.
I think you are. Hydrolysis.
Oh, hydrolysis? That's pretty cool. It's the opposite reaction to neutralization. That's when a salt and a water turn into an acid and a base. My dad's calling me. Hey, Dad. How you doing?
You're dead. I think you mean parent acid bases. Listen, dude. Acid-base parents are easy. All you need to know is the salt. Once you know the salt, you can determine both the acid and the base if you add water.
Peter, what about titration? The purpose? To determine the concentration of an acid or base through neutralization reactions. What about acid-base titration? Oh, okay, so the burette is filled with a standard solution of known concentration M, and then the Erlenmeyer flask contains a solution of unknown concentration. So that's when we use the titration formula, which is the molarity of the acid times the volume of the acid should equal the molarity of the base equals the volume of the base.
You're a natural, kid.
Wow, an A+. I guess there's a little bit of pH Peter in all of us.